Hello and welcome to A's Level Mathematics. This is Umar Katan and I'll be your instructor throughout this training series. This reading is based on coordinate geometry and will cover the most tested concepts in the GCSE, IGCSE, CAIE, ORC, Edexcel, International Baccalaureate and more. Main topics in this reading are as follows. So what is distance formula? Midpoint formula. Finding the gradient and working over the condition of the gradient. How to find the equation of a line. Finding the equation for the perpendicular bisector. And finally, I will walk you through multiple past paper questions step by step so you know exactly how to handle these questions in the final exams. So, let's get started. First, in coordinate geometry, we will be having a look at distance formula. The distance formula is d is equals to square root x2 minus x1 whole square plus y2 minus y1 whole square. Distance formula is mostly used in finding the distance between two coordinates. For example, we have this point A, which is 1, 2, and this point B is 3, 4. And we want to find the distance between these two coordinates. So we have this A1, 2 and B3, 4. It would be better if you could just write this in xy form as well. Alright, so just apply this formula for finding the distance between the 2 points. So distance of AB, I can even write it like this, and then take the root. The formula says x2 minus x1, so 3 minus 1 plus 4 minus 2 square. And then upon simplification we get Now let's talk about midpoint formula. The formula for the midpoint is mx comma y is equals to x1 plus x2 divided by 2 comma y1 plus y2 divided by 2. We have 2 points A 1, 2 and this B 3, 4, and we want to find the midpoint of this A and B or the line AB. So it should be here somewhere. And I have to find this point. So what I'll do for finding this point, I would just substitute all the values that I've got there in this formula. So this will become mx comma y is equals to, we know that this is our x1 and the y1, and this is x2 y2. So just substitute the values. So we have 1 plus 3 upon 2, comma 2 plus 4 upon 2, and this will give us 4 upon 2, comma 8 upon 2, which is equals to 2 comma 4. So that's how we find the midpoint of any line or in between the coordinate. That's how we do it. So M is the midpoint of the line AB, that is 2 comma 4. Now concentrate over another tricky kind of question that most often tested in the exam related to midpoint formula. Alright, now considering this question, we have a line AB. A has the coordinate x comma y, which are unknown, and B has the coordinate 3 comma 4. Whereas M is the midpoint of this line having coordinate 2 comma 3. We have to find the coordinates of A by using the midpoint formula. Let's see how do we do it. We know the formula for the midpoint is mx comma y is equals to x1 plus x2 divided by 2 comma y1 plus y2 divided by 2. So we have this thing like it should be like x1 y1, this should be x2 y2, and this 2 comma 3 should be equals to x comma y. So I will just substitute the coordinate of M in the formula, that is 2 comma 3. What's about our x1? This is equals to x only because it's unknown. What's about x2 comes from over here, which is 3 upon 2 comma y1 is y plus y2 is 4 upon 2. Now what we have to do, we just have to compare this x part with this and this y part with this one. So 2 is equals to x plus 3 upon 2, and this 3 is equals to y plus 4 upon 2. Upon solving this, we get x equals to 1, and this y is equals to 2. So we have this point 1 comma 2. Similarly, you can do this for B also if you want to find, like for example, in some question, if they just don't give you the coordinates for B and they give you coordinates for A, then you can do the same method and you'll find your answer. Alright, so now gradient is just the slope of a line or how much a line could be steeper. It is actually represented by M having the formula y2 minus y1 upon x2 minus x1. Normally gradient are of two types, like one could be positive and the other one could be negative. So how would you know if your line is having the positive gradient or the negative gradient? If you have a line going downward like this, then it will have negative gradient. This is called the negative gradient. If you have a line which is going somewhat like this, so this is positive gradient. Alright, now let's take a graph and try to find the values. Trying to find the how do we actually find the gradient. Let's see, 1 comma 2, this part B is 3 comma 4, and we have to find the gradient of this line. M is for gradient, and you're finding the gradient of line AB. So how do we do it? Again, very important thing, if you just write these coordinates in this form, that would be pretty helpful. So x1 y1 x2 y2, just substitute those coordinates in the formula and you will find it. So m of AB is equals to 4 minus 2 upon 3 minus 1, 2 upon 2 is equals to 1. So we are having the answer for the gradient of AB, which is plus 1, and as you could see in this graph, this line is going upward obviously, so that's why we are having positive gradient. Alright, let's talk about some condition for the gradient. In parallel condition, if two lines are parallel to each other, their gradients will be the same. What they mean by this is m1 should be equals to m2 if there is a line 1 and the line 2, and if they are parallel to each other, so they would experience the same gradient, which is m1 equals to m2. Let's assume if these two lines AB and CD, if they are the same, so I mean if they are parallel to each other, then they would experience the same gradient. So let's find out. M of AB is equals to 4 minus 2 upon 3 minus 1, which is 2 upon 2 is equals to 1. Let's find the gradient for the C and D also. So M of CD should be equals to 8 minus 4 upon 6 minus 2 equals to 4, should be 1. So see, the answer for M of AB is equals to M of CD. So it means that these two lines are parallel to each other. Now let's talk about the perpendicular condition for the gradient. Alright, in perpendicular condition, if two lines are perpendicular to each other, their products of gradients will be minus 1, which means m1 multiplied by m2 should be equals to minus 1. If the two lines, like the line L1 and the line L2, alright, in this case we have two lines, line AB and the line CD. As we can see over here, this line CD is perpendicular to AB. So let's find it by our gradient thing, if we could just prove it. So the gradient of line AB will be, we have the coordinates having the formula y2 minus y1 upon x2 minus x1. I should write here the formula first. Alright, so y2 minus y1, which is 4 minus 2 upon 3 minus 1, which is 2 upon 2 equals to 1. Now let's find the gradient for the line CD. 4 minus 3 upon 1 minus 2 minus 3 is 1. 1 minus 2 is minus 1, which is minus 1. So let's substitute this in our equation. M1 into M2 equals 2 minus 1. So we have the answer for M1, which is 1. I will write here 1. And the answer for M2, which is CD, is, I should better write it in this form, like M of AB and M of CD. So M of AB is 1, M of CD is minus 1, which is equals to minus 1. So hence proved, if the two lines are perpendicular to each other, their gradient, their products of gradient will be minus 1, and it is proved. Now let's concentrate over a tricky question. This question is often tested in the exam when you've been given with the line's coordinates, like what are the coordinates of A and B, but you don't know about the coordinates of C and D, and they have given you this information that the CD line is perpendicular to AB, and you have to find the gradient of CD. So how would you do it? We actually know the formula, which says M1 into M2 is equals to minus 1. So if first we will try to find the gradient of AB, which is needed in here. The strategy would be to find the gradient of one line, and by using that gradient find the gradient of the other line. Let's see how do we do it. So M of AB will be 4 minus 2 upon 3 minus 1. So 2 upon 2 is equals to 1. So we will just substitute this value of MA of B, MC of D is equals to minus 1. I will just substitute the value of M of AB, which is 1. I will substitute it here and would be able to find the gradient of line CD just by shifting this one to the right side, and it will become minus 1. So the gradient of the line CD is minus 1. This is the most important question, and you need to keep in mind they could trick you by just giving the coordinate for just single line, and they're not going to tell you what are the coordinates of the other line which is perpendicular to this line. Now let's talk about how to find the equation of a line. We have the general equation for finding the equation of line, that is y equals to mx plus c, where m is the gradient, c is the y-intercept. C is the y-intercept, which you could see over here. This is the point where when a line is intersecting y-axis. So it is right now passing through this one. You can use this equation, and there is another equation which you could use, which is y minus y1 is equals to m into x minus x1. So I am going to definitely tell you, it's up to you whatever equation you want to use. So you should know probably both the method of using the equation. So first we will talk about this y equals to mx plus c. We have the coordinates a1, 2, b3, 4. First we will use this for finding the gradient, and the gradient will be 4 minus 2 upon 3 minus 1, which is 1. Now we have to substitute the value of the gradient in this equation and any one coordinate. Either you take A or the B, it's up to you. No hard and fast rule here. It's up to you. You can use any of the coordinate in your equation. So I am considering this coordinate A 1 comma 2. So y is equals to 2, m is 1, this x is 1 also. You could see here this is your x and y right now, and we have to find the value of c first. So 2 minus 1 is equals to c, and c is equals to 1. Alright, so once we have found the value of c, just substitute it back into the equation y equals to mx plus c. Now we know the value of c and the value of m, which is important. Just substitute it back into the equation and your equation will be ready. So m is 1, x will remain the same, and this c is also 1. So we have this equation y equals to x plus 1. So this is the equation of this line. Now let's see how do we use this equation for finding the equation of line. So we have this equation y minus y1 is equals to m into x minus x1. Normally or personally I like this equation pretty much, but it varies from person to person, so it's up to you whatever equation you want to use. So let's draw the diagram again. This is 1 comma 2 and 3 comma 4. You have to find the equation of this line AB. So how do you use this y minus y1 equals to m into x minus x1 for finding the equation of this line AB? What I need here is this gradient and any one point. Either I could use A or I could use B. So I would like to use now B. It doesn't matter, you could use any of the point. So this will be my x1 y1. So I will just substitute this value in it. The gradient I know already, 4 minus 2 upon 3 minus 1, which is 2 upon 2 equals to 1. Just substitute this into the equation. Y1 is 4. From here y1 is 4 is equals to m is 1 also, then the x minus x1. So x will remain the same, this x1 is 3, so my y minus 4 is equals to x minus 3. Shifting this minus 4 to the right side, so y equals to x minus 3 plus 4, and y is equals to x plus 1. So that's how we can use any of the equation. Either you want to use y equals to mx plus c, or either you want to use y minus y1 equals to m into x minus x1. It's up to you. Alright, so now in this one we'll have a look at the question where one line is parallel to the other line. As you could see in the question, find the equation of the line passing through the point A and parallel. What does that mean? When two lines are parallel to each other, we have already discussed this property. Whenever two lines are parallel to each other, so the gradient of first line would be the same or would be equal to the gradient of the second line. So over here, line is passing through point A 2 comma 1 and parallel to the line y equals to 2x plus 5. So it means that this line has the gradient m is equals to 2. If you could see here, this is m equals to 2, this is the gradient. the line that is passing through the point A will also be experiencing the same gradient because they both are parallel to each other. If m is equals to 2, then I am going to make an equation through it. A2 comma 1, these are the points, and m equals to 2. So whenever two lines are parallel to each other, you need to take out the gradient from the other line and then substitute it back to the equation. We have the equation y equals to mx plus c. Either you can use this equation. I would prefer to use this equation. Y minus y1 is equals to m into x minus x1. So just substitute all the values in it. So y minus 1 is equals to 2, x minus 2. Then this equation will become y equals to 2x minus 3 upon simplification. That's the key to this question. Now look at the another question in which we'll be having a straight line will be passing through A and perpendicular to the line. Now in this question we have to find the equation of a straight line passing through A and perpendicular to the line y equals to 3x plus 1. Most important thing is this perpendicular condition. Whenever we know that if one line is perpendicular to the other line, so it should be equals to somewhat like this. Even you can say m2 equals to minus 1 upon m1. So we can use the gradient of this equation for finding the gradient of the other line because they are perpendicular to each other. So we have m is equals to 3 from here. Now I will put it back into this one so that I could get the gradient for the perpendicular equation. So minus 1 upon 3. So this is the gradient I got for my next equation. Now I will definitely and we have also been given with the point that is 2 comma minus 3. So we have this Chernal equation y1 y minus y1 is equals to m into x minus x1. So y minus minus 3 substituting x1 and y1 from this part A, m is equals to minus 1 upon 3, this x and this x1 is 2. Let's talk about perpendicular bisector now. If a line is bisecting the other line into half, whenever I say bisect, it means that the line is going to cut the other line into equal half. So let's say A, B, C and D are the coordinates. AB, there is a line AB and there is a line CD, and this line AB or this line CD is perpendicular to the line AB and it's making a 90-degree angle because we say perpendicular, so it should be 90-degree. And when we say bisector, it means that this line CD is breaking down this line AB into equal half. For example, if this is 4, then it should be 4 also because it is equally divided. Now we have to see how do we actually find out the equation for the perpendicular bisector. Let's take a question. Alright, let's draw a diagram first. We've been given with the AB. We have to look for a line which is bisecting this line AB, and this should be the midpoint. So first we will try to find the midpoint of the line AB because we need this point. could be x comma y, or it could be anything. The strategy is to find the midpoint first. First you have to find the midpoint of the line. Then you have to find the gradient, perpendicular gradient. Alright, so first finding the midpoint of AB. The midpoint of AB, we call it C over here. So C x comma y will be equals to 1 plus 5 upon 2 comma 2 plus minus 1 upon 2, and it will give us 3 comma 1 upon 2. Now we have to find the gradient of this line first, of the line AB, and then we can convert the gradient of line AB into CD by perpendicular condition, and we know that m1 into m2 equals to minus 1. If I know the gradient of this line, so I can find the gradient of this line by using this one. Alright, so the gradient of line AB will be y2 minus y1 upon x2 minus x1, so it will be 2 minus minus 1 upon 1 minus 5 is equals to minus 3 upon 4. This is the gradient for the line AB, but we don't need it. What we are looking for, we want to find the gradient of this line CD. Good thing is that we know that if a line is perpendicular to the other line, so we can use this formula. This will become minus 1 upon MAB. So minus 1 upon minus 3 upon 4 will be equals to 4 upon 3. Now we have found the gradient of the line CD, and the points of this intersection is 3, 1 comma 2. Now we'll just apply our general equation, that is y minus y1 is equals to m into x minus x1. So y minus 1 upon 2 is equals to 4 upon 3 into x minus x1 is 3. Alright, so upon solving we get 6y is equals to 8x minus 21. So this is the required equation of perpendicular bisector. Now to further solidify our concept, we will have a look at some past paper questions. In this question, the curve y equals to 9 minus 6 upon x and the line y plus x equals to 8 intersect at 2 points. Find the coordinates of the 2 points. This question seems pretty simple because a line and the curve is intersecting with each other, and we just have to look for the point of intersection. We know the method, we just simplify them by just substituting them equals to each other, or finding the value of y from one equation and substituting it back into the next equation. That's how we do it. It's pretty simple. So I'm going to just equate these two equations with each other. So y equals to 9 minus 6 upon 8 minus x will be equals to 9 minus 6 upon x, and we'll start solving it by taking 8 minus x is equals to 9x minus 6 upon x. Then 8x minus x square is equals to 9x minus 6 we have already converted our equation into a quadratic one. X squared plus x minus 6 is equals to 0. Factorizing it accordingly, plus 3x minus 2x minus 6 is equals to 0. Then x plus 3 into x minus 2 is equals to 0. And the x values are x equals to minus 3 or x equals to 2. Now substituting, first we should have written here how we actually converted this equation, or how do we find the value of y out of it. So y equals to 8 minus x, then 9 substituted over here, y equals to 8 minus x in it. Alright, so once we have found the values of x out of it, now I'm going to substitute this x values in the y equation, and we find 8 minus 3. Alright, so when x is equals to 2, y is equals to 8 minus 2, y is equals to 6. So we can write these coordinates like this: minus 3 comma 11 and 2 comma 6. So these are the x and y values when this line and the curve intersect with each other, so they would be definitely meeting at those points. Alright, in the next question, the equation of the perpendicular bisector of the line joining the 2 points. So we have to find the equation of perpendicular bisector of the line joining the 2 points. So these are the 2 points that I am going to write on the next page. Let's say these are the points A and B. So we have to find the equation of the perpendicular bisector. So let's suppose this is A and B, and there is a perpendicular bisector that is cutting this line. So minus 3 comma 11 and 2 comma 6. The step for finding the equation for the perpendicular bisector is first to find the midpoint, and that's how we gonna do it. Let's say this midpoint is C, right? This is C midpoint. So Cx comma y will be minus 3 plus 2 upon 2 comma 11 plus 6 upon 2, and this will give you minus 1 upon 2 and 17 upon 2. So these are the midpoint that we have already found. Now what we need to find, we need to find the gradient of this line. And how are we going to do it? We know just one thing, that this line, this perpendicular bisector is bisecting this. This is perpendicular to this one. So what I'm going to do, I will first find the gradient of this AB and will convert the gradient of AB into CD by applying the perpendicular condition that we have studied previously. So gradient of line AB will be 6 minus 11 upon 2 minus 3 will be minus 5 upon 5 equals to minus 1. So if the gradient of line AB is minus 1, then the gradient of this line, let's say this is line CD, so CD will be minus 1 upon m of AB, which is minus 1 upon minus 1, and it will be 1 only, plus 1. Alright, now we have found the gradient of line AB, that is 1, and the coordinate of C, that is minus 1 upon 2 and 17 upon 2. So I will just substitute it back into my equation. Y minus y1 equals to m into x minus x1. So y minus 17 upon 2 is equals to 1, and x minus 1 upon 2. So finally I'll get this equation y minus x is equals to 9. So that's how we actually find the equation of perpendicular bisector when you've been given with just 2 points, and you can apply this method for finding. This is most often tested in exams, so you need to concentrate over it. Alright, move on to the next one. In this question, the curve y square is equals to 12x and the line intersecting at 2 points. So this is pretty simple. Whenever a line and the curve intersect with each other, and you have to find the distance between the 2 points. So for finding the distance between the 2 points, first we should know what are the coordinates where they are meeting. First we'll find those coordinates and then we will apply the distance formula and we are done. Alright, so first convert this equation, make y the subject. So this equation will become 4 upon 3 x plus 6 upon 3, which will be y equals to 4 upon 3 x plus 2. Now I'll just substitute this equation into this curve, that's it. So 4x plus 6 upon 3 whole square is equals to 12x. Now upon simplification you will get 4x square minus 15x plus 9 is equals to 0. Then obviously you have to apply the middle term breaking or the factorization method, or either you could use quadratic formula or completing the square method. It's all up to you. I would suggest or prefer to use middle term breaking here, and you can see how I actually taught middle term breaking in the previous videos. You could see over there. So 4x minus 3 into x minus 3 will be the roots, and I will substitute equals to 0, finding the value of x out of it, and x equals to 3 upon 4. Now we have found the value of x, 3. Now we have to find the value of y out of it. So the value of y will be, for when x is equals to 3. So I'm going to substitute 3 over here. So y equals to 4, 3 plus 6 upon 3 will be 6 only. So I will write this coordinate like this: x comma y is equals to 3 comma 6. That's very important. Sometimes students make so many mistakes, like substituting the value of x from some other coordinate and then meeting it up with some other coordinate. So definitely it would make a big mistake. So you need to be cautious while doing this. Now the next, when y is equals to, when x is equals to 3 upon 4, substituting again in it, 4, 3 upon 4 plus 6 upon 3, 4 with the 4 gone, 9 upon 3, which is 3. Alright, the other coordinates that we have is 3 comma 4 comma 3. Now we have to find the distance between these 2 points. So just apply the distance formula for finding. Let's say this is A and this is B. So just apply the distance formula in between them. So the distance of AB will be root 3 minus 3 upon 4 whole square plus 6 minus 3 whole square. And AB will be equals to 81 upon 16 plus 9, which will be equals to 15 upon 4, 3.75 units. And that's it. That's how we find the distance between the 2 points.